In this example, we have 3x to the fourth plus 2x cubed minus 8x plus 6 divided by x squared minus 1. Because we're not dividing by a monomial, we are going to have to use long division to divide this. So the first thing that we have to note that's important for long division is that we have to make sure that every single power is represented. And what I mean by that is if we take a look at this polynomial right here, we can see that we're starting with the greatest exponent of 4. So we need to have every single exponent represented from 0 to 4. So we have the fourths, we have the cubes. Notice we're missing a squared term. Then we have x to the first, and then we have essentially x to the 0 power, no x's. All right, and the same is true here. When in what we're dividing by, we have x squared, but we're missing the regular x term. So when we put this into long division, we're going to have to put some placeholders. We're going to have to use some zeros for those terms that are missing. So let's go ahead and set this up. So I'm going to rewrite this. 3x to the fourth plus 2x cubed. And then I'm going to write plus 0x squared minus 8x plus 6. And then I'm going to put that in my division box. All right, hopefully this looks familiar. Maybe it reminds you a little bit of elementary school. Now we're going to put this, what we're dividing by, out here. And also, because it's missing a term, we're going to have to put a placeholder. So I'm going to write this as x squared plus 0x minus 1. So the first thing that we're going to do, just like we would have done if we were dividing just regular numbers like in elementary school, is we're going to take the very first term and we're going to divide it by this first term. So I've written the steps here for the pattern, or what the steps that we use. It's very repetitive, but we're always going to divide first, then multiply, then subtract, then bring down. And we're going to keep doing that until we can't anymore. So off to the side, I'm just going to write down 3x to the fourth. And remember that we're only dividing by the first term. All right, so we're going to do divided by x squared. And this gives me 3x squared. All right, so this is the first part of my answer, and it's important to always line everything up in columns. So these are all the fourths, these are the cubes, these are the squares, and so on. So because my answer, the first part of my answer is a square, I'm going to put it right in the square column, 3x squared. So I divided, now I'm going to multiply. So I'm going to take this term, and I'm going to multiply it by every single term in the divisor right here. So I'm going to do 3x squared times x squared, and that gives me 3x to the fourth. So because it's a fourth, I'm going to put it in the fourth column, or in the column for the fourths, or the power of 4. So 3x to the fourth, and these should always match. If you've done this part correctly, these must match, because when we subtract, those are going to cancel out. The next thing I'm going to do is 3x squared times 0x. Well, that gives me 0x cubed. 3x squared times a negative 1, so negative 3x squared. And then there's nothing else to divide by. So I've divided, I've multiplied. I'm sorry, there's nothing else to multiply by. So I've divided, I've multiplied, now I'm going to subtract. So 3x to the fourth minus 3x to the fourth cancels. 2x cubed minus 0x cubed is positive 2x cubed. 0x squared minus a negative, so a minus a negative makes plus, so 0 plus 3 is 3x squared. All right, and then I'm going to bring down the next term. And from here, I'm going to start all over again with this pattern. Once you go through it, you just keep going until you can't bring down anymore. So I'm going to start with division again. This time, I'm going to take the first term here, so 2x cubed, and I'm still going to divide it. Let me just fix that. I'm still going to divide it by this first term. So anytime you're dividing, you're only using this term. Just ignore these for the division step. So 2x cubed divided by x squared, well, that's going to give me 2x. So that's a 2x to the first power. That's a positive 2x to the first power. So I'm going to go ahead and put that in my answer above the x column. So now I'm going to multiply. So 2x times x squared is 2x cubed. Notice how these match. That's perfect. 2x times 0x is going to give me 0x squared. And then 2x times negative 1 is a negative 2x. So next step is to subtract. So 2x cubed minus 2x cubed is 0. 3x squared minus 0x squared is 3x squared. A negative 8x minus a negative 2x, that can change to plus plus. So a negative 8 plus 2 is a negative 6x. All right, and then I'm going to bring down the next term. And that's a positive 6. So once again, because I was still able to bring down, I'm going to just go through these steps again. This time I'm going to take this first term, 3x squared, and I'm going to divide it by this first term again, x squared. So that equals 3. So I'm going to go ahead and put that in the column where my constants, my regular numbers are. And then I'm going to go ahead and multiply. So 3 times x squared is 3x squared. Notice once again that these match. That's a good sign. 3 times 0x is 0x. 3 times negative 1 is negative 3. Next we subtract. So 3x squared minus 3x squared is 0. Negative 6x minus 0x is negative 6x. 6 minus a negative 3, remember that changes to a plus plus, so we have a positive 9. Now notice that I can't bring anything else down. So this is when we're done. But we have this left over. Remember that when you were doing long division in elementary school, if you had something left over, that became the remainder. So the way that we write remainders is with a fraction. So what we're going to do, and there's a couple of different ways you can do this, but we're going to do plus, and then I'm going to write the remainder as the numerator of my fraction, and that is going to go over the original divisor. So here I have a 0x, but that really simplifies to x squared minus 1. So whatever you were originally dividing by is what your denominator would be. And so our final answer looks like this. You could technically, if you wanted to, you could pull out a negative, so you could make this minus, but then you have to factor a negative from both terms. So either one of those options is okay. All right, so we have 3x squared plus 2x plus 3 plus negative 6x plus 9 all over x squared minus 1. And that's our final answer.